This is the week in which I reveal to you that I subsist on a diet of coffee and sparkling water. I should probably go to the grocery store. If you reflect on your daily life, you pretty much already know what lists are. You keep all kinds of lists, to-do lists, grocery lists. In Python, they're the same. They're essentially just groupings of items. Sometimes they're in an actual order, but sometimes they're just together because they belong together. There's no hierarchy or presumed order. To my right, you'll see one such list. The 4 names I call my cat the most often, and those of you who are cat owners get it, you call your cat their actual name the least often. So over on my right, I've got the boss, Snooze Magoo, Mr. U, and the main man. Those are 4 names that I call him. Probably call him the boss the most often. So when we're talking about this list, we might say that the first item is boss. The second item is Snooze Magoo. One thing to kind of check out is I've been doing this all semester, and I haven't really been calling attention to it. I've been starting numbering things from 0. When we start to talk about lists, and we talk about, for example, the first item on the list, we actually start counting from the number 0. So while we can confidently say there are 4 items in this list, if we were to number them as they actually appear in what we'll see as the data structure of the list, they actually start from 0. So technically, the numbering is the boss is in the 0th position. The number that we associate with each of these items is kind of like a row on a list. It's what we refer to as their index. So when we refer to things from a list, we are usually calling them by this kind of a number. And it's a little bit different, so you might want to memorize the fact that when we're talking about lists or other data structures, we're really talking about a formula that might help you when you're thinking about indexes. It's n minus 1. So the number of items in the list minus 1 is really where things live in the list. So again, if I were to talk about the third item on the list, it's actually in position or index number 2. And if I were to think about the last one, even though it is 4th, it's actually in index number 3. Of course, a bunch of words on a screen are not a Python data structure. If I were to see the list of my cat names put into such a data structure, it might look like this, which introduces a new symbol that we haven't seen yet, which is the square bracket. And it's important to keep brackets and braces separate because we're going to be using both in the next few weeks. The brackets border the list. And just like if I were writing a function, all of my values are separated by a comma. These all happen to be strings. They're all just characters and symbols. So they're all bounded by the double quotes, and each item is offset by a single comma. Once we have this, we can confidently say a few things about it. We can say it's a 4-item list, but more importantly, we can also ask questions about it. If I don't know how many items there are in the list, or for example, if I were to add to, which we will see in a future video, add to the list and not necessarily know how much I've added to the list, there are some things that we could find out about the list using built-in functions in Python that allow us to ask questions about it. And this is what my list looks like if I'm actually going to put it in a code platform. If I shift enter and I run my list, of course I have my list defined as cat names. If I were to print it, you notice that I see my 4 values. Now, lists are always going to print laterally like this, even if I try to make them pretty by doing the line-by-line version that you see above. But what are some of these questions that we can actually ask about this particular list, now that we see that we have data in it? Well, one thing that we can ask is we can ask for the number of items. And I'm going to say numNames equals a new function that we haven't seen before, but should be fairly common sense following some other ones that we've used, which is the len function, which takes 1 argument, which is the name of the data structure that I want to get the length of. And if I go ahead and print that, so print numNames, I should get what I believe is the right answer, which is 4. I have 4 items there. So I'm just going to see a 4. So that's one question I can ask about it. But like I said, if I try to get, for example, the last item there, and I do something like print cat names, and I use my square brackets to indicate that I want a specific index, if I look for index number 4, you see that I run into what's called an index error. The index error reads that the list index is out of range, which means there is no item 4, which if you were watching in the previous part of the video, actually would be item numbered 5 if we had 5 items in the list. However, the last item is actually item number 3. So if I wanted to correct this, I could shift enter here and I'd see that this is in fact the last name in my list. So being able to declare a list, to ask how many items there are in a list, be able to find what items are in what index, that's all well and good. But you're probably asking to yourself, well, can I add things to a list? Can I remove from them? Yes, you can. And to do that, we have to detour into something called methods. Now, a note I want to make about methods before we go any further. As we work on methods in future weeks, you're going to see that they are necessarily different from object to object, item to item. Things that work on lists don't necessarily work on strings, don't necessarily work on this thing we're going to see in a couple of weeks called a dictionary. They all have different, what I might start referring to as powers. And those powers are specific to the object. So they do special things based on what kind of object we're trying to modify. And in this case, lists have the ability to add and remove, and we're going to see how to add and how to generally use a method. So you can apply this to general use of methods throughout as we work through the coming weeks. So I forgot one name, and the name that I forgot is, I was going to tell you I call him the Bugman, and that's one name that I call him. So I'm going to use cat names because that's the variable I want to modify. I'm going to use a dot to separate my variable and my method, and I'm going to use the append method. Now, append is just a synonym for add and allows us to add to the end of the list, so I'm going to add the Bugman. And then I'm going to print cat names to prove that I've done this. And in a previous section of this video, you saw that this was an error, but now that I have 5 items in my list, I can actually ask for cat names number 4, and I get the Bugman. But I'm also kind of embarrassed that I just told you that one. So I want to take it away from the list. Well, good, I can do that. I can use cat names, the variable, again, I want to modify, dot the method I want to use on it, remove, and I'm going to remove the Bugman because I don't want you to see that anymore. That's a kind of embarrassing name, and I'm pretty sure the boss would probably also be kind of embarrassed that you know that. So I'm going to remove it, I'm going to print cat names, and we're going to see that we're back to our original list. So just a short video to talk about a few basic things about lists. In this video, we saw how to declare a list, we saw how to use methods on a list, we saw a couple of the built-in functions like len that we can use to ask questions of a list. Many of you already probably have some ideas on how lists can work for us in programs, and we'll see that this week, of course, in our activities and our lab. But for now, we'll leave it at syntax, and I'll see you in the next video.